Welcome to the world of software engineering, where we try to make computers what we want, and when they don't, we just blame it on user error. My name is Pranav Singh, and I'm a master student in software engineering. And in this video, I'll be taking you through to a not so boring journey through software engineering, where I'll be giving you an oversight and little bit of everything what happens in software engineering. So let's get started. All right. So what is software engineering? Well, software engineering isn't just about writing a code. It's about the structured and scientific approach to build reliable and maintainable system softwares. The term was first introduced at the NATO conference in the late 1960s and to deal with what they call the software crisis. And the fact that the large software companies and the large softwares often failed was because often they were late or they were running off way over the budget. So that is why they were often failing. And today, the software engineering helps us emerge to manage the complexity and build systems that can last years, even decades, while staying reliable and maintainable plus efficient. So that was about a little information about software engineering, and you can see on the screen there were some bullet point mentioned over here which you can take screenshot or write a note in your notebook, and I will see you in the next slide. So now let's understand software engineering versus software programming. A lot of people have their questions in their mind that what is the difference between the two? They sound very similar, and that's indeed true. But I'll try to explain to in my language. Programming is like a quick project. Write code and move on. But software engineering is all about teamwork, managing huge complex systems and making sure your software doesn't collapse even after years of use. Basically, you write it once and it's your problem for life. So that's how it is. And that's what I have written in this slide, that what is software. If you can see this, I will just move this over here. So if you can see this, software programming versus software engineering, sorry, software engineering versus software programming. So programming is write code and pray it works, and software engineering is write code, also plan for teams, deadlines, and budget overruns, built to handle large teams, multi-layered systems, and software that needs to run smoothly for years, because nobody wants to write it in the next year. Like, and the last point, it's also summing up everything. It's like, think of team battles versus solo battles. Yep. Alright, now let's dive into software process and developments. So, software engineering isn't a one and done deal. It's a comprehensive discipline that covers everything from understanding what a user needs to ensuring the software works flawlessly over time. So, it's like being a parent. Once you have created your child, your software, and you can't just leave it alone. It integrates various fields like project management, quality assurance, and user experience design, and in ensuring a holistic approach to build software that meets real world needs. Just remember, building software is all about creating a robust system that adopts and evolves instead of just hoping for the best, you know, because nobody wants to find out their masterpiece has turned into a bug museum. So this is what the points even states over here, that it encompasses multiple disciplines, requirements, analysis, system design, coding, testing, and maintenance, because you just can't build it and forget it. As always, you can write a note of these bullet points written over here, or take a screenshot, and I will see you in the next slide. So now let's cover one of the most important topics in software engineering, that is software cost and the sad truth. So software development costs a lot, like a lot. Fun fact, maintenance is often more expensive than development. The software breaks just when you thought you are done. Alright, building software is like buying a fancy car. Development is upfront cost, maintenance is when the car breaks down every 3 months. and your wallet cries a little each time. But it's always good to maintain your software. Okay, now this topic and slide is correlated to the last slide which we have discussed. It's about managing software costs. So over here I've written that software production is equals to development plus maintenance. Development is just the beginning. Maintenance is the real marathon. Keeping software running and evolving after launch. Maintenance costs often surpass development. Over the software's lifespan, maintenance can account for the majority of total cost. It's not just about building, it's about keeping the system alive. And you can see listed in the maintenance breakdown, there are three important points which you all need to remember. And those are corrective maintenance, adaptive maintenance, and perfective maintenance. So fixing bugs and errors that pops up after software is deployed, because nothing is perfect at the launch. Updating the software to stay compatible with new tech, hardware, or regulation. It's like giving your software a makeover to fit in with the latest trends. Perfective maintenance, enhancing the software based on user feedback and performance improvements. It's all about refining and optimizing the system for better results. All right. So software production is a two-part journey, I would say. First comes development, where you build the software, but that's just the start. The real test is maintenance, which takes over once the software is live. Think of it like buying a car. Again, I like giving these examples. So you design it, assemble it, and then spend years of maintaining it. Over time, maintenance can cost like over time, maintenance cost can overweigh the initial development cost of the software, because you're constantly fixing the bugs, corrective, which we have read before, and adapting to the new technologies and environment, and improving performance based on our user feedback, that is perfective. In short, keeping software running smoothly is a long-term investment. Trust me. Okay, so now we will be discussing unique challenges in software engineering. I've mentioned few of the topics over here, few of the main points, which you can always stop the video and take a screenshot or write it down in your notebook. And these are three really unique challenges, I believe, which everybody who is a software engineer faces. All right, so now let's discuss those. So software engineering presents a unique set of challenges. First, there's the sheer complexity of the systems we build. Modern software has thousands of moving parts, and if one tiny piece breaks, the entire thing can fall apart. Just like when you pull the wrong piece in the Jenga and it falls off completely, it's like that. So like it has like a lot of moving pieces in software engineering, and I'm referring to the lot of pages of codes which people write. So it's like that. And next we deal with human intensive processes. It's not just about writing code, it's about getting everyone in a team on the same page, coordinating tasks and making sure everything works together. So that's how it is. So it's a team job, like we have studied this before in the first slide. So this is what software engineering is all about, you know. It's not just one person building his own program. It's a lot of people are involved in building a software that works flawlessly in these days. So yeah, so that is why it is written like it is a little human intensive. And finally, there's software malleability. Software is never truly finished. There's always a bug to fix, a feature to add, or a new requirement to meet. You are essentially working with something that can always be reshaped for the better or worse. All right, now let's discuss how we can estimate software development resources. And I have break down this topic into three points, and those are mentioned over here. Like I told you, you can always take screenshots of it, and this is like these 3 points will give you a proper insight or knowledge what happens and how people estimate the software development cost. And I will explain in my words as well. So estimating software resources in software development is like predicting the weather. It's never perfect, but we still give it a best shot, right? So first up there is expert judgment, where experienced engineers use their knowledge and sometimes their gut feeling to predict how long and complex a project will be. It's like asking an old timer, like how long it will take to fix something. So then we have analogy based estimation, which is like saying, well, if this similar project took 6 months, so ours should too, right? But of course, things never go exactly as planned in software engineering. But uh, there's always people who will find their way through. Finally, there's algorithmic cost modeling, where we bring in the numbers, plug everything into a formula, calculate based on the complexity, team size, and other factors. It's as close as we get to scientific approach. But even then, surprises happen. Okay, that brings us to the end, and that was the journey, a little journey through software engineering. To me, software engineering is a wild ride. One day everything is running smoothly, and the next you are hunting down a bug at 3 a.m. It's a field full of constant learning, adapting, and solving problems that you didn't even know existed. But that's the beauty of it, it's never boring. And every project is a new challenge, and we humans are designed to conquer new challenge after new challenge, right? And whether you're working solo or part of a team, the goal is always the same: create something that works today, grows tomorrow, and finger crossed, it doesn't break when you release it. All right, that wraps up our journey for this video, and thanks for sticking around. If you like this video, you can hit the like button and consider subscribing, because there is more coding chaos to come. And just remember, every bug is just a feature waiting for discovery.